So assume we take this second problem from the proof worksheet. Okay, anytime you're looking to show congruence of triangles, you have to fit one of those four patterns: SSS, SAS, ASA, or AAS. Okay, so in looking at this, if we label some of the pieces of information, Q is the midpoint of PR, so we know that PQ and QR are going to be equal. QT and PR are perpendicular, so we know that this is going to form a right angle here. And we want to prove that these these halves of the whole triangle, are congruent to each other. Okay. So let's start with our givens. Q is the midpoint, and QT is perpendicular to PR. All right, so in the past proofs that we've done, I always begin with introducing the elements from your end state. In this case, the end state is a congruence of triangles, so what we need to do is find those three corresponding pieces of information that are congruent. I've labeled one of them based on the fact that our given is the midpoint, so I can make that statement that PQ and QR are equal. And how do I know that? What would justify that statement? Not bisect, or it is bisect, but the word that they used instead of bisect was midpoint. So we can use definition of midpoint to identify that piece of information. Now, what I'm going to do on the side here when I'm looking to show congruence is I'm just going to label my parts. I have a side here. And now, as I label this, do understand that the order that these appear vertically isn't necessarily going to be the pattern that you use. It might be, but it's not necessarily the case. We're just looking until we get three elements. Once we get three elements, then we can look for our congruence pattern. Okay. There's another piece of information that I labeled here, and that is that angles 1 and 2 are both right angles. Okay. And what do you know about right angles? All right angles are equal. That's one of the postulates, right? Way back from chapter 3. Okay. So we know that these angles 1 and 2 are equal to each other. So we need to introduce that. So in order to say that, what we want to do is we want to say that, or again, we can go one of two ways here. We could say that angle 1 and angle 2 are right angles. And the reason we know that is the definition of what term? This symbol represents perpendicular. Okay, so by definition of perpendicular, we know that angles 1 and 2 are right angles. Therefore, their measures are equal. And we know that because of the postulate, all right angles are equal. Okay, now, over here I'm going to write the other possibility. Steps 3 and 4 could have also been written as the following. You could have said that measure of angle 1 equals 90 and the measure of angle 2 equals 90. And that could be justified also by definition of perpendicular. Perpendicular means that the angles are either 90 degrees or they're right angles. You can interpret it either way. If you chose to use this as a statement in your proof, that the angles are each equal to 90 degrees, then your statement 4 would still be angle 1 and angle 2 are equal to each other. But what would the new justification be if we had gone this route? Transitive property, good. So either transitive property or substitution would have been your reason. And so it is possible to have these statements be slightly different than what I have, but it's really going to be one of these two choices. Okay, so once I find this, that these two angles are equal, I can now label that A, because now I have a pair of sides, now a pair of angles that are equal. So what I either need to show in this case to prove congruence of triangles is I could go ASA. So if I knew that angles 5 and 6 were equal, I could state the congruence of triangles. Or this side, QT, and use SAS. Can I say that QT is congruent to both? Yeah, it's the same one, right? So this is that one case where I'd mentioned that it'll come into play later, but we wouldn't really use it until then. And that is, if something is equal to itself. Do you guys recall what that axiom is? It is reflexive property. And so here is reflexive property. QT is equal to itself. That gives me another side. Now again, when I look vertically here, I do see that SAS, it fits the pattern that it actually is. But that's not always going to be the case. Because could I have said QT equals QT as step 2? Yeah, you can move these around. They don't have to fall in this particular order. But once you get your 3 pairs of elements, you now look to see, does it fit one of the patterns that you can use to show congruence of triangles? And if it does, in this case SAS, 2 sides in the included angle, well, I can write down my end state congruence of triangle PQT and RQT. And my justification is, again, 2 sides in the included angle, 2 sides, the included angle would be my final statement. Okay. Now, so this would be the end to this proof. Okay. I want to add one more thing just so you can kind of see. If instead of this, this proof stating, prove that PQT and RQT are congruent, what if this proof had asked us to prove that PT is equal to RT? Okay. If it had asked us this particular step, we would have one final step to this proof. You'd still need to show congruence of triangles. What do you know once you have congruence of triangles? What's the relationship between the corresponding parts? They're all congruent, right? That's what the congruent statement says. So is it true here that PT and RT, based on this statement, are going to be equal? Yeah. So that would be our 7th step, would be to reach that conclusion that PT and RT are equal. And there's 2 possible ways to defend this. And the one that we've already discussed is simply when we look at the congruent statement, we can call it definition of congruence. Okay. The other way that's commonly used is called CPCTC. Okay. And what CPCTC stands for is corresponding parts of congruent triangles are congruent. Okay, so if you see the acronym CPCTC, that is what it stands for. It's just another way of saying definition of congruence. So if you have a statement that 2 things are congruent, then by definition, all their corresponding pieces, they are equal in all respects. Okay, CPCTC stands for equal in all respects. All right, again,